This video is on exercise 9D A-level maths pure 2 textbook. Question 1. Differentiate A, which is x, so we can call this y is equal to x times 1 plus 3x to the power of 5, and we want to differentiate this. So this exercise is mostly on product rule, but that doesn't mean that we don't want to use the rules that we've already been taught. So we are probably going to use things like chain rule and some of the standard differentiations that we learned. Right, so we write divided by dx is equal to, okay, so we can differentiate the first function first, which is 1, because x differentiates to 1 times 1 plus 3x to the power of 5 plus, now we write down the first function and then we differentiate the second one, which is 1 plus 3x to the power of 5. So that becomes 5, because that comes down, times inside, which is inside differentiated, the derivative of inside is 3. Open bracket 1 plus 3x to the power of 4, be careful. And now we can simplify this to write 1 plus 3x to the power of 5 plus 15x times 1 plus 3x to the power of 4, and that's it. It's very tempting to even simplify things further once we have used the product rule, but I suggest you not to do that unless they asked you for a specific form. B, y is 2x times 1 plus 3x squared to the power of 3. So again, the same as the previous one, we differentiate the first bit, which is 2 times the second bit, and plus, now we write down the first bit times the derivative of the second bit, which is 3 comes down, and 3x squared differentiates to 6x times 1 plus 3x squared to the power of 2. And let's simplify this. 2 times 1 plus 3x squared to the power of 3. And here we have 6x times 6x, which is 36 squared times 1 plus 3x squared. C, y is equal to x cubed times 2x plus 6 to the power of 4. Again, the same process. So we differentiate the first bit, which is 3x squared, times the second bit, 2x plus 6 to the power of 4. And now plus the first bit times the derivative of the second bit, which is 4 times 2 times 2x plus 6. So the power of that minus 1, which is 3. And we can simplify this. 3x squared times 2x plus 6 to the power of 4. Now here we have 8x cubed times 2x plus 6 to the power of 3. And that's it. D, y is equal to 3x squared times 5x minus 1 to the power of minus 1. Divide by dx is equal to, the first bit differentiates to 6x times 5x minus 1 to the power of minus 1, and then we write 3x squared times the derivative of the second bit, so minus 1 comes down times 5, which is the derivative of inside, and then we have 5x minus 1 to the power of minus 2. So we have 6x times 5x minus 1 to the power of minus 1, and minus 15x squared times 5x minus 1 to the power of minus 2. 2. We have e to the minus 2x times 2x minus 1 to the power of 5. So the first bit differentiates to minus 2 e to the minus 2x, because that's an exponential function. We only differentiate the power, and that comes down as a coefficient. Then this times 2x minus 1 to the power of 5 plus e to the minus 2x times 5 times the derivative of inside, which is 2, and this times let's write here this, times 2x minus 1 to the power of 4, and let's simplify that, minus 2e to the minus 2x times 2x minus 5 to the power of 5, and you have plus 10e to the power of minus 2x times 2x minus 1 to the power of 4. B. Y is equal to sine 2x times cos 3x. Divided by dx is equal to sine 2x differentiates to 2 cos 2x times cos 3x, and we now write down the first bit times the derivative of the second bit. So sine 2x times cos 3x differentiates to 3 times, so cos 3x differentiates to cos x by its own differentiates to minus sine x, so that here we have minus sine 3x, and we get 2 cos 2x times cos 3x minus 3 sine 2x times sine 3x. C. Y is equal to e to the x times sine x. Divided by dx is equal to e to the x differentiates to e to the x. So nothing changes, because the power, which is x, differentiates to 1, and 1 times e to the x is just e to the x. E to the x times sine x plus sine x differentiates to cos x, as we said, so that we get e to the x times cos x. And finally, sine 5x times the natural log of cos x. So the derivative of the first bit, which is sine 5x, is 5 cos 5x times the second bit, ln cos x. And now we write the first bit, which is sine 5x times, right, so ln cos x. Whenever we have ln of something, the form is like this. So let's say we have ln of, so let's say g of x is equal to ln of f of x. So this simply means that we have a function, and that function is the natural log of another function. Then the derivative is this. So g dash x is equal to the derivative of the function that is inside. So that's f dash x on top, and then on numerator is just f of x. So this form is very useful if you can memorize this, because it helps you to differentiate the functions that are involved within ln of something much quicker. In this case, so we have ln of cos x. So cos x differentiates to minus sine x, and cos x is the function, so we write that down. And hopefully you can remember that sine x over cos x is tan x, and here is minus, so it's minus tan x. Just simplifying that, 5 cos 5x times ln cos x, and here minus sine 5x times tan x. So this minus comes from here. And that's it for this video. Thank you for watching, and make sure to subscribe for more videos. Good luck.